Welcome back to the channel. This video is on hydrology and we're looking at the factors controlling a flood hydrograph and its dynamics. So what changes can occur to affect the hydrograph of a river within a certain system, a watershed, or a drainage basin? This is the Earth Science Classroom. A hydrograph is a visual representation of a certain point along a river's channel. Could be the upper course, middle course, or lower course. But this particular location on the river is showing you the velocity of the water, the flow rate, and the cross-sectional area of the river channel, which is the width times the depth. And this will give you the discharge, the amount or volume of water flowing down the river in the channel at one point in time at that location. And this can be shown on the hydrograph, showing the changes in height or volume of water in the river based on seasons, based on various factors that can change the amount of water that is entering the river and the speed at which it's flowing through the channel itself downstream. Now these factors are climate, the soil characteristics, the land use and cover, and topography. Now these four factors can change how much water is in the river at any one time and fluctuate across time and space in terms of location within the river system and the watershed. Now these four characteristics will be discussed in this video in how they affect the hydrograph and how they also combine together to create a dynamic hydrograph of any major river. A hydrograph can be affected by climate through obvious addition or subtraction or removal of precip based on the temperature, wind direction, humidity, weather patterns, and obviously climate, which is a long-term viewpoint on daily weather patterns over a 30-year period at least. So with more or increased precip, you'll have an increased volume or discharge of water, so the hydrograph will reflect this with a high amount of precip. A medium and a low would be obviously a smaller volume of water, which would be close to, if not just the base flow, which comes just from the groundwater. So again, depending on the amount of precip that is falling in the watershed or the catchment area, it will reflect directly into the hydrograph and also show a lag time between that peak rainfall and the peak height of the river, reflecting how fast the water is falling on the catchment area and then entering the river. Soil can have a great effect on a river's hydrograph. Now, soil is a combination of mineral composition of sand, silt, and clay, clay being the smallest and very effective at absorbing water and holding water with a large water holding capacity. And you have the porosity and permeability of that soil will greatly affect how fast, how much water is allowed through the soil, absorbed in the soil, and also be transmitted through the soil, called interflow, and eventually into the groundwater, which will create the base flow. So the speed at which the water goes through the soil will directly affect the river's hydrograph. So if the soil is compacted and won't let any water through, no infiltration or percolation allowed, it will become more impervious and it will create a larger amount of surface runoff, again based on the gradient, and the lag time will decrease and the increase of water will be reflected in the higher height of the river or discharge, compared to if you have a large amount of porous and highly permeable soil with limited clay and more sand. You'll have a lot more water infiltrate and percolate through, both in groundwater and in interflow, and it will delay the water to get into the river channel and be reflected in the hydrograph. A river's hydrograph can be affected by the land use and the land cover of the surrounding watershed or catchment area or drainage basin in which the river is a part of. So the river channel is generally the lowest part of this watershed, and the flow of water down through a gradient or slope will eventually make its way into the river and be reflected in the hydrograph. So with an impervious, a rock-based or a non-porous soil, or an artificial or man-made surface, you'll have a greatly increased volume of water entering the river a lot quicker through overland flow and surface runoff, versus a porous or pervious surface, allowing water to go in. Also, you have the effect of vegetation. Vegetation has a great effect at absorbing and trapping and intercepting water, not only from the atmosphere, but also from the soil and from the roots, and not only holding the soil in place to reduce soil erosion, but also to uptake water for the plants and vegetation. So the forest cover, the forest type, the old versus new growth forest versus various biomes and landscapes with vegetation types, that will greatly influence the rate of water entering the soil or not, and entering the river and being reflected into the hydrograph with the change in river discharge or height. The watershed or the catchment area or the drainage basin's topography, the shape of the land, the relief, the landscape, can greatly affect the hydrograph and the amount of water that is flowing into the river at certain times. For example, the gradient, the measure of a slope. A steep slope will allow water to rush down and enter the river at a much faster pace than a gentle slope or even a flatter plateau landscape. So gradient will affect the velocity of the water entering the channel and the velocity through the channel itself in terms of the course of the river, upper course, middle course, or lower course. Then you have the volume or amount of tributaries, streams and brooks, and first and second and third order streams that will eventually add into the main river through confluences and provide the additional volume of water, again reflected in the hydrograph. So the bifurcation ratio, or RB, is a number between 2 and 5 that gives you an idea of how many first and second order streams are providing this main river with water that is caught from the catchment area and then transported either as base flow, as interflow, or on surface runoff through these brooks and creeks and small streams. Then you have the size of the watershed itself, the actual square kilometers or square miles, how big the watershed is, or the catchment area. The larger the catchment area, generally the larger the amount of discharge and the larger base flow, but this will be reflected in additional precip by an increase in discharge and height of the river shown in the hydrograph. So the landscape and the geology, the gradient, and the size will greatly affect the river's hydrograph. Each of these 4 criteria that affect the river's hydrograph, climate, soil, topography, and land use and cover, are all discussed separately. However, in a real watershed or a catchment area or a drainage basin where that river is being measured for its discharge and shown in the hydrograph, all 4 of these criteria have a large influence when they work together on any flood hydrograph. For example, the climate will have a large influence based on the amount of precip versus dry and wet seasons versus the wind direction versus humidity versus the elevation or latitude in terms of seasonality. Is it close to an ocean? Is it continentality? Away from an ocean? All these factors will affect the amount of rain that's going to fall, or the type of precip that will fall on this watershed, and that would then affect the soil quality, the soil thickness, the soil composition, the topography, the weather and erosion, the shape of the land in terms of the gradient, or even the bedrock geology will have a great effect on how much water is allowed through in terms of groundwater flow, interflow, interception, surface runoff, overland flow. The land use would have a great effect and control over the water's flow over the land in terms of vegetation, in terms of root systems and retaining water, in terms of surface runoff and how fast it's going to move into the river. You can discuss soil erosion based on the gradient and the climate in terms of flash flooding or more consistent rainfall. So all these criteria naturally connect and overlap and interlink to create a very dynamic and changing effect on the amount of water that is going to enter into a river channel and then is reflected in the flood hydrograph. So a change in the land use in terms of any additional impervious surfaces added by humans, or the removal of trees, vegetation, or the change in climate due to atmospheric CO2 or sea level change would have a great effect on the river's hydrograph and how the river is affected by these changes. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.